Hello, so in this video I'm going to talk about the logic operators in software engineering for mathematics, and I'll be using the logical operators in Java, but there is one problem. Now the symbols used in software engineering for math are different from the symbols used in Java. So for instance, the symbol for O is not on my keyboard. Then Java uses a different key on the keyboard to represent it. So the symbols are different. The only similar symbol is the one of ZO, which is tilde. So okay, let's go ahead to look at logical operators. So the logical operators which we have, and the ones which I'm going to look at, are the logical AND, logical OR, logical ZO. So logical AND. Logical AND is written with this symbol in Java. It is written with the AND symbol. Then logical OR is written with a pipe symbol, which is this. Then logical ZO is written with the tilde. Which is this. Sorry, this is not logical ZO, this is logical NOT. Logical ZO is written with this symbol. So there is a mixture between the math and Java. But if you're coming from MOOC, then you will have to just shift the symbols in case you're doing math and in case you're doing Java. But for Java, we're just doing it as a lesson. Then we also have the NOT operator. The NOT operator, I don't want to call it logical, but let me call it logical. So this is the logical NOT. Now I'm going to go ahead and generate the truth table. These logical operators, except the NOT, work on two operands, the left and right operand. So we want to see when the logical AND returns true. So let's check that out. So to check that out, I'm going to get the two operands, which are mainly Boolean operands, the true or false. So in software engineering for math, there are two operands, we call them P and Q. So let's go ahead and look at what the truth table is when both P and Q are true and we are using logical AND. So let me first create the booleans here. So boolean P equals true and Q equals true. Now I want to check what the truth table is for logical AND, considering that both P and Q are true. So to do that, I'll just print out another boolean, which I'll create here. So boolean truth table, let me call it TT. Okay, I'm supposed to write clean code. So the truth table would be P and Q. So the boolean truth table would be P and Q. Then I'll have to print out the truth table. So right now we just want to know what the truth table is like. And I'm going to do the truth table for all the logical operators. Then we are going to consider that this first one is for AND. Then the second one is for O. So I'm just going to reassign truth table to another variable, which is P O Q. So this first one here, which I've clicked on, is the one for AND. Then the second one is for O. Now let me do the one for ZO. Then we can also deal with the NOT operator. But the NOT operator only works on one operand. And it's very simple. If the operand is true, it turns to not the operand, which is going to be false. And if the operand is false, it turns to not operand, which is going to be true. So for that, we can just do S out. So I'm going to do not P and not Q. So this not operator cannot be applied to booleans. It only works on numbers, like binary numbers. So I'm going to leave it for this case. But as I said, when the thing is true, it turns it the other way around. It's like if you're male and the not is applied to you, you turn female. But it doesn't work on booleans. So let's go ahead and run, and we see how the truth table looks like when both P and Q are true. Then we shall also change when one is true and then when both are false. So for now, let's run. So we can now check out the results from here. So the first result is for this first one here, which is P and Q. So we can see that the truth table is true when both P and Q are true. So the truth table for logical AND is true when both P and Q are true. Then the truth table for logical O is also true when both P and Q are true. But the truth table for logical ZO is false when both P and Q are true. So we can also test the truth table by shifting the values of P and Q. But I'll leave you to do that in maybe your free time. So for now, I'm going to go ahead and answer some of the logical questions that you will find in your math papers, maybe. I don't know, because I'm also like you, student. So the question, they give you a value of P, which is a certain value. Like for instance, in this question, we have that P is equals to it's raining and Q is equals to it's cold. Then the question is, it is raining and it is not cold. So to answer this question here, we shall have to first identify P within the question. So if you are to look at this question, you will find that P is simply the word from where I'm going to highlight. So you realize that the whole of the highlighted word is P. So you quickly put P at that position. Let me highlight it and put P. So now it is P. Then I look for where Q is. Q is saying it is cold, but in the question we don't have it is cold. We have it is not cold. So for you to represent this highlighted word with Q, it is going to be impossible. But you can represent it with not Q, because not Q fits well. Since it is cold is the same as, since it is not cold is the same as not it is cold. Okay, that doesn't make sense in English, but it's the only way you can do it in math. So first try to identify Q, it is cold, then here it's cold, but there is a not in the middle. So to relate this statement with this, we have to change this to the negative part. To relate the highlighted statement with this statement here, we shall have to put a negative on this one to make it negative. So yeah, now this, since we have the positive part, we shall change it to the negative, which is going to be not Q. So now after replacing the words in the question with the representation of PQ, then you look at the logic which is combining the two. So the logic which is combining the two is the logical AND. Then you replace that logical AND with the logic operator AND. So that means you have finally answered the question. So if I'm to go back to the question, this would simply be answered as P and not Q. So basically this is how you answer it. Then when you come here, P is sleep, Q is rest. Then the statement is saying you can either sleep. Now I've found where P is. P is this one. I highlight it and just replace it with P. Then I look for where Q is. Q is here. I highlight it and replace with Q. Then the logic operator which is combining them is this one, O. That means I'll just replace it with the logic operator O. So at the end of the day, this becomes the answer, P or Q. So then we come here. P is I'm a man, Q is I'm a woman. Then the statement is saying I'm a man and not a woman. So I first look for where P is. This is P. Then not a woman. Since it is not a woman, I'm going to put not Q, because Q is a woman. Then the operator in between is the AND operator. And then I replace it with AND. And finally I've answered the question. But there is also another way of answering this very question, because you can see I'm a man and not a woman are just opposites of the other. So in cases where you have opposites, you can easily use the ZO operator. So the answer would simply be P ZO Q, because being a man and a woman are opposites of each other. So thank you for watching.